Welcome back to the Math Professors. If you enjoy content that can be found in any college math class, please consider liking, subscribing, and sharing. I'm Professor Van Hamlin, and I'm going to cover how to solve a system of equations using an inverse matrix. So what I've given us, I get an example of a system of equations, and what we know is we can write this, in multiple forms now that we've reached this point of class. So we can write it in its augmented matrix form, and we know we can just row reduce that in order to get the identity that over here are going to be your solutions. But something more sophisticated is we can write this in matrix multiplication form. We can call this 2, 3, 1, 4 multiplied by, the variable is equal to this matrix 5, 10. So now what we have is we have something of the form, we'd say a matrix A multiplied by a matrix X is going to be equal to a matrix B. And you can see this is your A, this is your X, and this is your B. So what we have is we have a linear equation, where all your elements are matrices. So how would we solve this? So let's just kind of go about this right here, just in the general. So what we have to do is we have to use the inverse. So what I'm going to do is I'm going to multiply the left-hand side of this by A inverse, and I'll also have to do that over here. So I have A inverse times AX is equal to A inverse times B. Now remember that, we're multiplying the A and the X right now, and we know that multiplication of matrices are associative, so what I can do is I can combine this A inverse and this A. What I mean by that is I can multiply that first and then this X second, then I have this, A inverse B. Now A times A inverse, we covered in the last lecture, is just I times X is equal to A inverse B. And I times X is, well, I is the identity matrix. It's just going to give you X back. So we're going to have X is equal to A inverse B. So if I want to solve for this, I just need to multiply this on the left-hand side by its inverse. This being A, this being X, and this being B. So what I'm going to have to do is I'm going to find A inverse by hand. And then we're going to multiply the left-hand side of both and kind of really like show this property. So let's find its inverse. So if I want to find the inverse of A, well, let's do it over here. So if I want to find, we know A is going to be equal to this. We do it this way, A, and we combine it with I. And then we'll row reduce that. So this is going to be equal to A, which is 2, 3, 1, 4. I is 1, 0, 0, 1. And I'm going to row reduce this to get to the identity. So we can do a switch row 1 and row 2. And I can make this a 0. So minus 2 row 1 plus row 2 is my new row 2. Minus 2 times 4 is minus 8 plus 3 is minus 5. Minus 2 times this, and this is 1. Minus 2 times 1 is minus 2 plus 0 is going to be minus 2. Now I can turn this 5 into a 1 by multiplying it by a negative 1/5. R2 is my new R2. So we're going to have 1, 4, 0, 1. And we're going to have 0. This is going to be 1. This would be minus 1/5. And this is going to be equal to positive 2/5. Now the last thing I have to do is turn this 4 into a 0. So since I'm in column 2, I'm going to use row 2. So we're going to have minus 4 row 2 plus row 1 is my new row 1. And this should do it. So row 2 is unchanged. And so minus 4 times this plus this is 1, minus 4 times this plus this is 0, which is what we're trying to do. Now this right here, we're going to have minus 4 times a fifth, so minus 4 times a fifth, plus 0, which is just going to be equal to, so minus 1/5 is going to be equal to 4/5. And over here I have minus 4 times 2/5 plus 1, which is going to be equal to 5/5. So this is minus 8/5 plus 5/5, which is going to be equal to minus 3/5. And now what we know is that when we're done, this is now going to be equal to I adjoined with A inverse, making this matrix over here A inverse. So let's do that. Let's multiply both sides of this by A inverse. So I'm going to have A inverse, which is this 4/5 minus 3/5 minus 1/5, 2/5, and we're going to multiply it by this over here. So 2, 3, 1, 4, this is going to be times x times y. And then I'm going to have the same thing multiplying the left-hand side by that same A inverse. So 4/5 minus 3/5. Let's make that look prettier. Boop, boop. There you go. Minus 3/5. Minus 1/5. And then 2/5. And then we're going to multiply it by this 5, 10. Okay. Now, I'm not going to do this step here. I'm just going to multiply A inverse times A. I really just want to verify when I multiply these two things, I do indeed get the identity, and then we know that we're going to get x back. So let's try this. So minus 4/5 times 2 is going to be 8/5. And then I have 8/5 minus 3/5 is 5/5. So I get 1. Okay, over here, first row, second column. 3 times 4 is 12/5. Minus 12/5 is 0. Over here, now second row, first column. This would be minus 2/5 plus 2/5, which is going to be 0. And then the same thing here. I have 2, so this is going to be 6/5. Sorry, my bad. This is going to be minus 3/5 plus 8/5, which is going to be 5/5, which is 1. And we still have this x times y. So we just verified that it was the inverse because it gave us I back. Well, we kind of verified on the left-hand side. And we know in order really to say it's the inverse, it's got to be, you have to be able to multiply A times A inverse as well. But this satisfies our needs of really getting rid of this matrix. Okay. Now over here, I'm going to multiply these things together. So I'm going to have 4/5 times 5, which is 4. 4 plus, well, I should say minus. This is going to be 30/5, which is going to be minus 6. And for this part, we're going to have minus 1/5 times 5, which is minus 1, plus down here, this will be 20/5, which is 4. Okay, now identity times x is just, our x, well, our variable. And this is going to be equal to minus 2, and this will be equal to 3. So kind of verifying that we found the solution that x is going to be equal to minus 2, and then y is going to be equal to 3. And we did that through finding the inverse. So if you like the content, please subscribe.